For over 45 years, Voyager 1 has been drifting through the cosmos, long past its original mission timeline. Launched in 1977, it was designed to explore the outer planets of our solar system, but against all odds, it has continued transmitting data from interstellar space. Now, after decades of silence on major discoveries, Voyager 1 has just sent back something that has stunned scientists, including renowned physicist Michio Kaku. At a staggering distance of over 15 billion miles from Earth, Voyager 1 is humanity's farthest-reaching spacecraft. It has traveled beyond the heliosphere, the protective bubble of solar wind that surrounds our solar system. What it has now detected is something that defies expectations, an anomaly that suggests interstellar space may not be as empty as we once thought. For years, scientists assumed that once Voyager 1 left the heliosphere, it would enter a quiet, uniform region of interstellar space. But recent data from its plasma wave science instrument reveals something different. Instead of an empty void, Voyager 1 has encountered persistent, low-frequency plasma waves. These waves indicate a level of structure and activity in interstellar space that we never predicted. Michio Kaku has described this discovery as one of the most unexpected findings of our time. According to Kaku, the presence of these plasma waves suggests that the space between stars is more turbulent than we believed. This could have profound implications for our understanding of how cosmic radiation, interstellar matter, and even distant alien signals travel through the galaxy. The plasma waves Voyager 1 detected originate from interactions between interstellar gas and remnants of solar activity. When the Sun ejects bursts of energetic particles known as coronal mass ejections, these waves ripple outward, affecting space thousands or even millions of miles away. But what's truly shocking is that Voyager 1 continues to detect these waves, even in the absence of strong solar activity. This suggests that interstellar space itself may have an underlying hum, a constant subtle vibration we never knew existed. Beyond plasma waves, there's another perplexing mystery Voyager 1 has uncovered. Some of its onboard systems have started behaving strangely. The spacecraft's attitude articulation and control system, which helps orient Voyager 1's antenna toward Earth, has been sending back garbled telemetry data. Scientists at NASA's Jet Propulsion Laboratory have spent months trying to decode the issue, but the cause remains unknown. Some experts, including Kaku, speculate that prolonged exposure to interstellar conditions may be interfering with the spacecraft's electronics in ways we don't yet understand. This raises an even bigger question. What else could be out there that we are not prepared for? If Voyager 1, a spacecraft built with 1970s technology, has already encountered these unexpected plasma waves, what would more advanced probes discover if they ventured even further? Could interstellar space hold hidden phenomena we have yet to detect? One of the most thrilling possibilities is the existence of yet undiscovered cosmic structures, such as interstellar magnetic fields or vast currents of charged particles. Michio Kaku has suggested that Voyager 1's findings could pave the way for a new era of space exploration, one that looks beyond our solar system to understand the fundamental nature of deep space. There is also an exciting discussion around what this means for future interstellar travel. If space is not as empty as we assumed, it could impact how we design future spacecraft. If subtle plasma waves are present everywhere, could they be harnessed for energy? Could they interfere with future probes? Or, more intriguingly, could they carry signals from distant civilizations? Voyager 1's mission was never supposed to last this long. It was designed to explore Jupiter and Saturn, not to become an interstellar explorer. Yet, despite its aging systems, it continues to challenge our perceptions of the cosmos. But the clock is ticking. Voyager 1's power supply comes from radioisotope thermoelectric generators, which are slowly running out of fuel. NASA estimates that by the 2030s, the spacecraft will no longer have enough energy to operate its instruments. When that happens, Voyager 1 will fall silent, drifting endlessly through space, a relic of human curiosity. Until that day comes, Voyager 1 will continue transmitting data, potentially sending back even more surprises. Michio Kaku believes that as long as we receive signals, we should listen closely, because we are witnessing history being made, one transmission at a time, and with each piece of data, we get one step closer to answering some of the universe's biggest mysteries. But what if Voyager 1's latest discovery is just the beginning? What if these plasma waves are only a small clue to something much bigger lurking in interstellar space? Michio Kaku and other leading scientists believe that we may be on the verge of uncovering hidden structures or forces in the cosmos that we never anticipated. For decades, we assumed interstellar space was a cold, silent void, but Voyager 1's findings suggest otherwise. If these plasma waves are constantly present, then the so-called emptiness of space may be teeming with unseen activity. One of the most fascinating theories emerging from this discovery is that these waves could be part of an interstellar medium more complex than we ever imagined. Scientists know that interstellar space contains a thin soup of hydrogen, helium, and trace amounts of other elements, but the presence of persistent plasma waves hints at underlying dynamics we haven't yet mapped. Michio Kaku speculates that these waves could interact with larger cosmic structures like magnetic fields or shock waves from supernova explosions. If that's the case, then Voyager 1 is essentially navigating a hidden ocean of energy, one that could have massive implications for our understanding of space travel, communication, and even extraterrestrial life. One of the biggest questions arising from this discovery is whether these plasma waves could influence signals traveling through space. Scientists have long wondered why we haven't detected clear extraterrestrial transmissions, despite decades of searching. Could it be that these waves distort, scatter, or weaken signals before they ever reach us? If so, then we may need to rethink how we search for alien civilizations. Voyager 1's ongoing journey also raises questions about the future of interstellar exploration. If space is not a perfect vacuum, but instead a fluctuating medium of plasma waves and unseen forces, how will this affect spacecraft traveling at high speeds? Could these waves act as resistance, slowing down future probes, or, in a more optimistic view, could they be harnessed as a form of natural propulsion? Michio Kaku has suggested that understanding these interstellar plasma waves could be a step toward developing new propulsion systems for deep space travel. If we can map and manipulate these waves, future spacecraft could potentially ride them, like ocean currents, reducing the need for conventional fuel. This could be a game changer for humanity's ability to explore the stars. However, there is another, more unsettling possibility, one that scientists are only beginning to consider. If these plasma waves are not random but instead structured in a way we don't yet understand, could they be the result of an unknown cosmic phenomenon? Could they be shaped by massive unseen forces at work in the universe? Some researchers have even proposed the possibility that certain plasma wave patterns could be artificial in nature, perhaps signals or distortions caused by something we have yet to detect. While there is no evidence to support this theory, yet it remains an intriguing question. Could Voyager 1 have stumbled upon a new form of cosmic communication? Even if these plasma waves turn out to be purely natural, their discovery has already reshaped our understanding of interstellar space. It proves that even in the most distant and unexplored regions, the universe is still full of surprises. Voyager 1 has defied the odds for decades, surviving the harshest conditions imaginable. And, despite its outdated technology, it continues to push the boundaries of human knowledge. As Michio Kaku has said, every time we think we have space figured out, something like this happens to remind us how little we truly know. For now, Voyager 1 continues its silent journey into the unknown, sending back whispers from a realm no human has ever seen. And as long as it speaks, we will listen, because the next discovery could change everything we thought we knew about the universe. Voyager 1's journey is a testament to human curiosity and determination, but it also raises an inevitable question: what happens when it finally goes silent? For over 4 decades, this spacecraft has been our cosmic messenger, sending back data that has reshaped our understanding of the universe. But its power supply is dwindling. By the 2030s, Voyager 1 will no longer have enough energy to keep its instruments running. One by one, its systems will shut down, and eventually, it will transmit its final signal back to Earth. When that moment comes, Voyager 1 will become a silent relic of human exploration, drifting endlessly through interstellar space. It will continue on its path for millions, perhaps billions, of years, long after every trace of human civilization on Earth has vanished. In 5 billion years, when the Sun expands into a red giant and consumes the inner planets, Voyager 1 will still be out there, traveling toward the unknown. But before that day arrives, scientists are racing against time to extract as much data as possible. Each new transmission is a window into an unexplored region of space. Voyager 1's latest discovery of persistent plasma waves has already rewritten what we thought we knew about interstellar space. But what if this is just a small piece of a much bigger cosmic puzzle? Michio Kaku believes that Voyager 1's findings could point to hidden structures in deep space, remnants of ancient stellar explosions, massive interstellar magnetic fields, or even unknown cosmic forces that we have yet to detect. Understanding these forces could be crucial for the future of space exploration, especially as humanity begins to set its sights on interstellar travel. Future missions, such as NASA's proposed interstellar probe, could build upon Voyager 1's discoveries. Unlike Voyager, which was never specifically designed for deep space exploration, a next-generation probe would be equipped with modern instruments capable of mapping plasma waves, measuring cosmic radiation, and detecting interstellar magnetic fields in ways we can only dream of today. But there is also something deeply symbolic about Voyager 1's journey. It carries with it the famous Golden Record, a time capsule filled with sounds, music, and images from Earth. If an intelligent civilization ever finds it, they will hear greetings in 55 languages, the laughter of a baby, and the sounds of nature, from a distant world they have never seen. Michio Kaku has often spoken about the possibility of extraterrestrial life. While Voyager 1 was never intended to find aliens, its golden record is a message to the cosmos, a silent declaration that we were here, that once a species called humans gazed up at the stars and dared to explore. And so, as Voyager 1 continues its lonely voyage, it carries with it more than just scientific instruments. It carries the hopes, dreams, and curiosity of an entire planet. It has defied the odds, outlived expectations, and expanded the boundaries of human knowledge. As long as it continues to send back signals, we will listen, because with each transmission, Voyager 1 reminds us that the universe is far more mysterious, complex, and wondrous than we ever imagined. And one day, perhaps, it will inspire a new generation to follow in its path, to go beyond, to reach further, and to continue the search for answers hidden among the stars.